Welcome to AskPrep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of physics, which is waves, types and properties of waves. This concept is fundamental for NEET aspirants as waves play a crucial role in understanding sound, light, and even quantum mechanics. A wave is a disturbance that travels through a medium, carrying energy from one point to another without any net transport of matter. Waves are present all around us, whether it's the sound we hear, the light we see, or even the ripples formed in water when a stone is dropped. Waves are broadly classified into two main types: mechanical waves and electromagnetic waves. Mechanical waves require a medium for propagation. This means they cannot travel through a vacuum and need air, water, or solids as a medium. Examples include sound waves, water waves, and seismic waves. Mechanical waves further have two types: transverse waves and longitudinal waves. In transverse waves, the particles of the medium vibrate perpendicular to the direction of wave propagation. A common example is waves on a stretched string or ripples on the surface of the water. In such waves, crests and troughs are formed, where crest is the highest point of the wave. Trough is the lowest point of the wave. On the other hand, in longitudinal waves, the particles of the medium vibrate parallel to the direction of wave propagation. Sound waves in the air are a perfect example of longitudinal waves. In such waves, we observe compressions and rarefactions. Compression is the region where particles are close together. Rarefaction is the region where particles are spread apart. Electromagnetic waves, unlike mechanical waves, do not require a medium for propagation. They can travel through a vacuum, which is why we receive sunlight from the sun despite space being a vacuum. Examples of electromagnetic waves include light waves, radio waves, X-rays, and microwaves. These waves oscillate in electric and magnetic fields perpendicular to each other and to the direction of wave propagation. Now, let's discuss some important properties of waves. The first property is wavelength, lambda, which is the distance between two consecutive crests or troughs in transverse waves, or the distance between two compressions or rarefactions in longitudinal waves. It is measured in meters. The second property is frequency, f, which is the number of wave cycles passing through a point per second. It is measured in hertz. The relation between frequency and time period is given by f is equal to 1/t, where t is the time period, the time taken for one complete oscillation. The next property is wave speed, v, which is the speed at which a wave propagates through a medium. It is given by the equation v is equal to f lambda. This equation shows that the speed of a wave depends on its frequency and wavelength. Another important property is amplitude, A, which represents the maximum displacement of a particle from its equilibrium position. A higher amplitude means more energy in the wave. One of the most important characteristics of waves is phase. Two waves are said to be in phase if they reach their maximum and minimum displacements at the same time. If one wave lags or leads another, they are said to be out of phase. Now, let's discuss superposition of waves. When two or more waves meet at the same point, their amplitudes add up or cancel out, depending on their phases. This leads to two types of interference. Constructive interference occurs when waves combine to produce a wave of greater amplitude. Destructive interference occurs when waves combine to cancel each other out, reducing amplitude. Another important wave phenomenon is resonance, where a system oscillates with maximum amplitude when subjected to a periodic force of its natural frequency. This is observed in musical instruments and bridges vibrating due to wind. Reflection of waves occurs when a wave strikes a surface and bounces back into the same medium. This is how echoes are produced in sound waves. Refraction of waves occurs when a wave passes from one medium to another and changes direction due to a change in speed. This is why a pencil appears bent when partially dipped in water. Diffraction of waves happens when a wave bends around obstacles or spreads after passing through a narrow opening. This is why we can hear sound even if there is an obstruction in the way. The speed of a wave depends on the medium through which it travels and is given by the equation v is equal to f\u03bb, where v is the wave speed, f is the frequency, and \u03bb is the wavelength. The phase of a wave describes the position of a point within a wave cycle and is crucial in understanding interference and wave superposition. Interference occurs when two or more waves meet, leading to constructive or destructive interference. In constructive interference, waves combine to produce a wave with a larger amplitude, while in destructive interference, waves cancel each other out, resulting in a smaller or null amplitude. This principle is applied in noise cancellation technologies and the formation of standing waves. Reflection, refraction, and diffraction are important wave phenomena. Reflection occurs when a wave bounces off a surface, following the law of reflection, which states that the angle of incidence is equal to the angle of reflection. Refraction is the bending of waves when they pass from one medium to another due to a change in speed, as seen in light bending when entering water. Diffraction is the bending of waves around obstacles or through small openings, which explains how sound can be heard even when the source is not in direct line of sight. Doppler effect is another crucial wave property, where the frequency of a wave changes due to the relative motion between the source and the observer. This explains why the sound of a siren appears higher when approaching and lower when moving away. Understanding wave properties is essential for solving any ET-level problems. Waves are fundamental in various applications, including medical imaging, communication, and even quantum physics. The best way to master waves is through practice and visualization. Thank you. Explanation helpful. Make sure to subscribe to AskPrep for more in-depth NEET physics content. Keep practicing, and see you in the next session.